Hello. Today we're going to look at section 7.1 and 7.2. And this is the first part of the lecture on those two sections. And we were just in 1.3, and we're jumping to 7.1, 7.2 because it talks about an application of linear equations. And what we're going to do is we're going to solve systems of two linear equations. And I'm guessing some of you may have seen this before in another algebra class, and there's two methods, substitution and elimination. And so I want you to understand those and also to understand the relation between the equation and the graphs of the lines that are given by each equation. So, oops, sorry, didn't mean to do that. So here's an example of a linear system in two equations. And I think I want to go right now to talk about how these define lines. And so I'm using a new tool today, and it's a pen that I have, and so it's going to be, just bear with me. So here we have these two equations, and I'm going to look at this equation first. So I'm going to write that over here, and just bear with me. I'm so sorry, I want to write it over here. Okay, so we're going to have like x plus, and I'll try to write slowly because I'm new at this, is equal to 4. And I want to solve for y in this equation, and there you'll see we get a line. So to do that, I'm going to subtract x from each side. And then these x's cancel, and I get y is equal to 4 minus x. And that's a line. So this equation, this first equation over here, let me turn that spotlight off. Oh, sorry, it's not cooperating. Okay, this first equation over here really is this line right there. Okay, so I'm going to do the same thing for the second equation. I'm going to do that over here. It'll go a little bit smoother the more we get used to that. So here, I'm going to bring it down here. So we have x minus y is equal to 2. And then here I'm going to add y to each side. I want to solve for y. So I'm going to add y over here. And then I'm going to subtract 2 from each side. And these cancel, so I get x minus 2 is equal to y. So I make that clear that that's a y. And this is the linear equation function that's based in the x minus y is equal to 2. Okay. So what we're going to do is we're going to learn tools to find out the same x and y that that makes both statements true, and we'll write the answer as a pair, and that answer will look like this. And the first one over here, this is my x coordinate, and this is my y coordinate. Now, we want to find the set of all solutions, and when we do that, that's called solving the system of equations. We'll go through this on the next slide. Okay, so here we're going to solve for this, and our method is going to be, we're going to take one equation, and it doesn't matter which one, and solve for one of the variables. Again, it doesn't matter each one. So I'm going to solve for y in this equation. We actually did this. So I do this. This is what I did over here, and I get y is equal to 4 minus x. Now what I'm going to do is plug that in for this y in here. And that's what I do here. And then I'm going to solve x. I go through the math here. X minus 4 plus x is equal to 2. Well, that's the same as 2x minus 4 equals 2. Sorry, 2x minus 4 equals 2. I add 4 to each side, add 4 here, and over here. Sorry. And then I get 2x minus 6, divide by 3, and I get x is equal to 3. So I know that that's one of the answers, is x equal 3, and now I have to find y. So to do that, I'm going to plug this 3 into this x right here, and then I'll just solve for y easily. I do that down here. Y is 4 minus x, y is equal to 1. So we get y is equal to 1 over here. Oops, sorry. Like I say, I'm getting used to that. I know it's kind of messy. I apologize for that. So anyway, so our solution is going to be xy is equal to, and I want to know, is that correct? So what I'm going to do is plug it into the next equation and see. So, so remember, we just saw that the solution there is 3, 1, so I want to check it. and I'm going to plug in the 3 for here, and then 1 for there, and see if I get a true, and I do. And I could also plug it in this equation over here if I wanted, and I'll leave that to you to do. It'll work there too. So if you want to check fully, substitute both equations. Usually just one is enough. Oops, sorry about that. So, okay, so to continue with this, I want to show what this looks like visually, and how do we know that we have only one solution? Well, again, we saw before that I could solve each of these equations and turn them into lines. So with equation 1, we get that, which we did earlier, and for equation 2, we get this. And these are two lines, and I graph them. And the first line is going to be in red, and the second is in blue. And then what you see right here is you get one equation. If you look closely, you see that, yes, that's going to be the point. The x-coordinate is 1, 2, 3, and the y-coordinate is 1. So that's what's going on. So when you solve this system up here, what you're really doing is you're finding where these two lines intersect. So there's algebra and geometry that's involved here. Okay. So that's called the method of substitution. There's also a method called elimination. And this is really useful when right away you see that the terms of x and y are the same or opposite, or that you can easily multiply one and to make them the same. And we'll see examples of each. So I'm going to start with this first one right here. And it's pretty clear. Here, let me move this over. It's pretty clear that these two are the same. Now what I can do is I can add, or they're opposite, I'm sorry. I'm allowed to add an equation to another equation. Remember, when you solve an equation, you can do the same thing to both sides. So since I can add -1 to 7, and since minus 3x minus 2y is also equal to -1, I can add that to this. And I'll do this on the next slide. So that's just the idea of what we're going to do. So here we go. There's the equation we were looking at. And then what I'm going to do right here, as I talked about it, I'm going to add these equations to one another. So when I do that, the 3x's go away, and I get my 3y here, 5y minus 2y, and 7 plus minus 1 is 6. So I get 3y here, and I get y is equal to 2. So that gives me y. Now, I need to find out what x is, so what I'm going to do is I'm going to substitute y equal 2 into either one of these y's, but I'm going to use this y right here. Okay, so I go down here, and I get 3x plus 5y equals 7, 3x plus plugging this 2 right into here, and I go through the math. I multiply 3x plus 10 is equal to 7. I subtract 10 from each side, so I subtract 10 here from each side. And then I'm going to get 3x is equal to -3, and then I get x is equal to 1. So I get y is equal to 1 there, I get x is equal to -1 here, and then my solution is right here. And again, I'm checking this. I'm going to plug -1 in for x here, and I'm going to 2 in for y here, and I get a true statement. So that's my check. And again, if I wanted to check, I could plug it into the second one if I wanted to do a more thorough check. So that's one example. So here's another one. And so here, what I'm going to notice is that if I multiply this equation by 4, so I multiply 4 here, and then I'll multiply this side by 4. Again, I got to do the same thing to both sides. What happens is I get a 4y here, I'm going to get a 20 here, and when I add these equations like I did before, it's going to cancel that. So let's go through that. So I start here, with the two equations, and I know I'm going to add them, so I'm going to put a 4 here, multiply this side by 4, and get 4 times 5 is 20. 4 times y is 4, so I get 20x plus 4y. Now I add them, and these are going to cancel. I add the x's, I get 22, and I get -11 here. So I divide each side by 22 here, and I get x is equal to -1/2. So that's my x-coordinate. Now I have to find y. So remember, I can plug x into either up here. Which one do you think is easiest to plug x in for? I got x equals -1/2. Well, to me, I realize that if I plug in -1/2 into, sorry, let me find it, into this x right here, I'm going to get 2 times minus 1/2, and that's going to be an easy multiplication. So that's what I do. And then I go through the math here. I get minus 1 minus 4 is equal to minus 7. I add 1 to each side to get rid of this term. Minus 4y is 6. Divide each side by minus 4. 3 over 2. And then I solve for y, and I get y is equal to 3/2 here. So I get y is equal to 3 over 2. Up here, I had x is equal to 1/2, minus 1/2. So that's my solution. Okay. Now I'm going to do the check. And again, I'm going to plug in the solution, which I have over here. I'm going to plug that into each equation this time, just to give you, so I get 2 times minus 1, 4 times 3, and I'm going to get minus 1 minus 6. Yep, that's equal to 7, so that checks. And I do the same thing here. I plug in minus 1/2 there and 3/2 here. I do the multiplication. I get minus 1 plus 3/2. That's going to equal, when I do the math, that's going to be equal to minus 2/2, and that's going to be 1. So it works out. So again, that's the method of elimination because I'm eliminating one of the terms. Okay, that's it for today, for this lecture. Not it for today, I'm sorry about that. That wasn't fair. It's it for this half of the lecture. So now I'm going to go on to talk about the second part of section 7.1, 7.2, and that deals with some of the geometry that's involved as well as some of the an application. Okay, so that's it. Hopefully that wasn't too rough, and I thank you for bearing with me as I learn how to use this pen. Thank you.